This is lecture 5 of Fundamentals of Surveying, and in this lecture we will cover the leveling process. And so you will remember that in the previous lecture we talked about differential leveling and I had a slide called Solving the Problem. You can go back and review that, but what I want to do here is just summarize it from scratch because that's what you need to be able to do. So if the terrain looks something like this, what you do is you have to figure out that if you're starting here, I'll call that point A, and you're going over here to point B, and you need to know the difference in elevation between those 2 points, that you set up a differential leveling instrument. These days, at least in the labs that you'll be using, it will be an automatic level. And based on how far apart these are, you then have to set up automatic level to transfer the elevation from one point to another, or transfer the relationship between points. So A and B, let's say, are permanent points. You wind up setting some point in the middle here that's basically a temporary point. And as it turns out, TP doesn't stand for temporary point, it stands for turning point, because that is an actual term used in the leveling process. So we have established then, once we properly set up the instruments, or the instrument, we will have horizontal lines of sight at both points. And so what happens then is that we would hold a level rod over point A, and let's say it has a certain elevation. So we know what its elevation is with respect to a certain datum. And we measure the rod reading, and that tells us how high our line of sight is, a horizontal line of sight is with respect to the point on the ground. Because we've just read off the rod reading, it tells us exactly how high that reference surface is. So we can actually calculate, if we know the elevation of point A and we know our rod reading, we can add those two to get the elevation of our line of sight, which is sometimes abbreviated HI for height of instrument. And then what we do is we sight this point over here, and so we get this rod reading, and so we can get the elevation of the turning point by subtracting that distance from the HI. Now this particular reading here is referred to as the backside reading because you are starting and you're kind of looking back, and this is called the foresight reading because you're looking forward. And sometimes these back sights are referred to as plus sights, and these foresights are referred to as minus sights. Why? Because you always add your backside reading to your elevation to get your HI, and then you subtract your foresight reading from the HI to get the elevation of the turning point. So you always calculate the elevations of your intermediate points. Then you repeat the process here with another foresight, which establishes a new HI, and then, that's a backside, and then you look forward and get a foresight, and so you can basically take the elevation of this turning point, add this new backside reading to it, subtract the second foresight reading from it to get the elevation of the point you're interested in. Now, if you really want to make sure that this is done properly, something that we will get into in the latter part of the lecture is that you don't stop there. You then repeat the leveling process back to your point of beginning or to some other known point to make sure if you have any blunders, mistakes, or errors in surveying, that you can either determine that they're small enough that you can deal with it, or that there is a major problem and it needs to be repeated. And so I can't really show that going back process here very easily because it'll cause a confusing mass of lines. But we do have an exercise, an example showing how that would be done to come back. So typically people just get to the objective and stop, but a good surveying process means always building a check into the process, and the check in leveling and differential leveling is to then survey back to the point of beginning and see if we get back the elevation we started with, or at least very close to it. And if it differs in a major way, and depending on the application of the surveying, a major difference can vary all the way from 1/100th of a foot to a couple of feet, then you would say something's wrong, we need to restart. Well, actually you start by checking your math, because it's very common, especially for students, to arrive at the wrong conclusion. So let's go on to the next slide here. And so here, what I'm going to do is talk about some of the terms again. So we have what's called the benchmark, and it's abbreviated BM. Benchmark is your starting point. They are known reference points. You often start your survey there. These are not published always, because they may be just a, if you will, a private survey benchmark that's been created by the team working on a particular project. But sometimes they're set by utilities, they're set by city government, they might be set by state government, and the various departments actually within the federal government also set benchmarks across the country. You always need to check very carefully to make sure you're using the right one if you need to be fitting into the datum system that somebody else created. But what's very common in engineering projects is that you already, the first surveyor there may have set up a benchmark. You need to find that benchmark, observe it, so that your leveling is done along the same datum that somebody else has done. Then we have the term backsite. I've already told you that's abbreviated BS. Height of instrument is abbreviated, this is a mistake here, it's abbreviated HI. Foresight is abbreviated FS. Turning point is abbreviated TP. Now we'll eventually get to this. There's also something called a side shot, sometimes referred to as an intermediate foresight. And I'll explain that as we get to it. But for right now, just be aware that this term SS is sometimes also used in leveling. So these are the abbreviations. I've kind of defined them. And let's move on. So the basics of the field process, this is a formal way of describing what I had informally sketched before, because I'm going to throw some additional information on. So this point here is benchmark A, and it has an elevation of 436.72. And you can see there are 3 setups of the level. And so it turns out the first backsite is 3.26, the second one is 5.26, the third is 5.51. Okay, so these are all backsites, so from the instrument coming back to the rod. And then we also have foresights, and in this case we have foresight of 4.98 to the first turning point, 3.11 to the second turning point, and 4.69 to this ending point, whatever we might want to call it. Now, you notice I have the word profile thrown in here. That's because there are 2 ways of sketching the field process. And to figure out the math, sometimes you might discover that it's helpful to draw the plan view instead. So be aware that depending on what you're doing, you may need to draw the plan view or the profile view to help you understand what's going on in the surveying process and the math that goes with it. Or you might have to actually do both, especially early in your surveying career. So here's the same setup, but now it's the plan view. So we have, again, this is benchmark A. We set up the level here, so these things are supposed to represent the legs of the tripod, these things in red. And so the blue lines represent the line of sight. And so typically what we would do is when we write rod readings, we might write 3.26 here and 5.26 here, because what's happened is we were set up here, we backsighted the benchmark, we foresighted it, then we pick up the level and move it over here. So remember that the turning point always needs to be a solid point that you can set up the rod on that's identical as far as elevation is concerned to when you foresighted it. And then the last back sight would be 5.51. And then you would write your foresights in 4.98, 3.11, and 4.69. So these are two ways of trying to visualize what it is that's going on, and especially early in the process, you may discover that you actually do need to write it both ways to help you understand what's going on. Or put it this way, when students have trouble understanding the process of leveling and create their field notes incorrectly or do their assignments where they're supposed to reduce a set of information that represents a differential leveling scheme, where they go wrong is when they don't take the time to sketch these things out. And as I said, depending on your proficiency and your understanding, you may actually have to sketch a plan and a profile view of the leveling. So here I have what would be called the field notes and calculations required to do this. So I'm going to switch back and forth between this slide and the previous one. But when we set up, the first one was called benchmark A, then we have turning point 2, turning point 1, turning point 2, and point Q. So if I go back here and I label these things, so this is benchmark A, of course. Here's turning point 1, here's turning point 2, and of course here's point Q, where our line of differential levels stopped. So now I'm going to go back to the field notes and point out that I'm actually going to cover two styles of field notes that are often used by surveyors. And this is probably the most common used by surveyors. It's very compact, it's very dense, and especially for new surveyors, and especially students, can be very confusing to follow along and figure out how to do the math. I myself, in my own survey work even today, do not use this. I will show you a different method. But because you could be exposed to both, especially if you encounter a work situation or your textbook, I want to make sure you understand what's going on. So first of all, I have the column headings. So I have the station, which is kind of the shorthand name. Then I have backside, and notice I put the plus sign next to it to remind me that these get added to the elevation to give me the HI. Then I've written foresight and put the negative sign to indicate I subtract the foresight from the HI to get the elevation, which is my fifth column. And then I have description because I may have other information that needs to be included. And I can use that column for that additional information that needs to be put in. So remember, in my previous slide, I had indicated that we had an elevation of 436.72 for our first point, benchmark A. When we set up, we took a backside of 3.26. So we took the 436.72 and we added the 3.26 to it, because remember it's a plus sight, to give us the height of instrument. That's the elevation of our horizontal line of sight. Then we turned forward and we sighted the rod held on turning point 1. You notice turning point 1 in the left-hand column. So we subtracted over here 4.98 from 439.98 to give us 435.00. Then what we did was we picked up the instrument and moved it forward and back-sighted turning point 1. So this is where it gets confusing for students sometimes. So this is still our same setup. We back-sighted turning point 1, we write the 5.26, and what we do is we take the 4.35.00, and like we did before, we then add it to the 5.26 to give us 440.26. And then we turn forward and observe turning point 2. Notice the row. So we did this to come up with 437.15. That's 3.11 subtracted from 440.26. Once we've taken the foresight on turning point 2, now we can move up to our last setup, and we backsight turning point 2, and we get this 5.1. So 5.51. So we do this, we add these two numbers together, which then gives us 442.66. And I subtract the 4.69 because I'm now at looking at point Q to give us our final value. So that's kind of how it goes back and forth, and you have to realize that we have turning point, because we have a line labeled turning point 1, that we don't write 5.26 first. We actually do the foresight to it first, then we come back and put in 5.26, and then we're able to calculate 440.26 and so forth. Something that I want to mention that students especially don't like to do is that you've got to do this math as you go along. So the additions and the subtractions are things you need to be able to do in the field. You need to do them as carefully as possible to make sure you're not making mistakes. You need to do it under duress because you might have traffic, you might have weather, you might have bosses and clients and construction machinery that you're trying to deal with. And so it can be a rather stressful situation. Plus you're not sitting down, you're holding a book in your hand. And so it's real easy, especially for students, to say, no, I'm going to fill my pages and pages of notes with my readings and calculate later. And there's a real problem with that because sometimes you need some of your intermediate elevations as you're going on, and now you have to stop and do a whole number of calculations. Now, the field notes are not finished because there's one final calculation that's done, and that's called the math check or the arithmetic check. And what we do here is we add up all the backsights. And here they happen to add up to 14.03. We add up all the foresights. They happen to add up to 12.78. So what we do now is that we say, what's the difference? So this is a subtraction. And because the foresights are negatives, remember the negative sign in the parentheses, what we always do is subtract the 12.78 from the 14.03 because we then compare that to this delta, and when I see this delta, I mean the delta between our starting elevation and our ending elevation. So if you look at this, we have 437.97 and 436.72. We get 1.85. So now we want to see if we get that same difference here. So, except because it's easier to subtract, I hope you can see that we have increased in elevation. But here I'm going to take the larger number, 1403, subtract the 12. So 13 minus 8 is 5. 9 minus 7 is 2. So what we get here is the sum of the foresights subtracted from the sum of the backsights is 1.25, and the difference in elevation between my starting and ending points should also be 1.25. That's what this delta equals question mark is. But you see here they're not. So one of the first things we do is we need to check the math. And so doing a quick check, I can see that I have a math mistake here, checking in between my first and my last elevations. So 7 minus 2 is 5, that's correct, but 9 minus 7 is 2. So I went the other way. And then 7 minus 6 is 1. So it's 1.25 and 1.25. So what this means is that our level notes then are correct, because we can't arrive at 1.25 when we do the subtraction between the sum of the back sights and sum of the foresights, and the difference between our starting and ending elevations. And so we always use a check mark. We always do that. So you have to. So as a boss, as an instructor, we will always be looking for check marks on your level notes to show that you did an arithmetic check. What's interesting about this math check is, let's say you have a page full of notes and another page full of notes and another page full of notes and then a half a page. So quite a bit of leveling that you've done. You don't have to wait till you get to the end to do the math check. You can actually perform a math check on every page of notes. So always leave some space at the bottom of every pair of pages to do your math check, because it gets very tedious to try and trace a problem if you only discover it at the very end. So that's how you do the field notes and calculations. Now that is one method to keep notes, where the backsight and the foresight to these turning points appear on the same line, which, as I said, is very confusing. So before I go on to the other style, I just want to remind you that for every backsight, at least in this case so far, there must be a foresight. We often suggest that you take redundant rod readings. That means, as a student, you might take your eye away from the telescope, move your telescope off the rod, maybe even have your rod person move the rod off the point, hold it back on the point, resight your telescope, and take another rod reading and see if it matches up to what you first read. And one of the things I tell people to remember is to place a plus sign next to the backsight, a negative sign next to the foresight on your column headings, because when you're in the field, you don't have your textbook, you don't have all these other pieces of information, and it can get a little bit difficult trying to figure out by rote whether you add or subtract backsight readings and foresight readings to elevations and from foresights, from heights of instruments. All right, so I've called this alternative field notes, and just to point out, that's the same figure that we're still using. So this, you'll recognize the 436.72 for benchmark A, the 3 backsights and the 3 foresights. But you see, these are a little bit more open, okay? And that's because what I've done is I said I'm set up at benchmark A, I'm foresighting my turning point 1, so there's turning point 1. Then I move up and I take a backsight on turning point 1. So it's pretty standard in surveying. If you haven't written your station number again, and you do that just because it's fewer things to write, that it's still on turning point 1. So these 2 readings, in one case it's a backsight, the other case it's a foresight, and you actually did the foresight reading first and then the backsight. Those 2 lines cover all the observations on turning point 1. The next 2 lines cover all the readings on turning point 2. And so your final reading, of course, is to point Q, which we already have. In other respects, the math, the numbers, everything else is the same. You can still do your math check. You'll still have this situation where you can add up your backsights and foresights, get the difference, calculate the difference between your starting and your ending elevations, and still do your math check, and to be able to signify that, yes, I have done the math check, my math checks out fine, and here is my survey data for whatever the next step in the processing happens to be. Now, one of the things that some people do sometimes is even throw in an extra line. So when you calculate the HI, you would put the HI on a new line. And that simply represents the position in elevation terms of the horizontal line of sight through the instrument. So where we've had these lines, we would actually add 3 extra lines where the HI is shown separately. HI is simply calculated and shown separately. So I just wanted to point out that this figure you've already seen before, the profile view, and I'm going back now to my previous slide, that these data shown here are exactly the same data as we had here, going back to slide 6, but I spread them out so that they're a little bit more open. And for many students, it's easier to follow. And I have to tell you that personally, I still do things this way because I can do the math and keep track of what I did in my mentally remember what I did and so forth a lot more easily. Okay, so now we're going to get to something involving side shots. Remember I talked about side shots and I said the abbreviation was SS and it stands for side shot, and sometimes the more formal name is intermediate foresight, or even sometimes IFS. And what a lot of people like to do is actually call them IFS or SS, depending on your preference. But what I have here is that similar line of leveling that we had before, except now what we have is some kind of an engineering or construction project. We want to do something more. So in addition to this line of leveling, we also have, again, benchmark A, except now it's 246.75. We have 3 back sites. But you see, we have many more foresights. We have 3 more foresights than we did before. And in this case, we have an extra foresight. That's a side shot or an intermediate foresight to the southwest, assuming north is to the top of the page, southwest corner of the building. Another one from the second setup to the southeast corner of the building, and then another one to this thing that it turns out is a manhole. So this is the situation that we are trying to show in our field notes, and so it looks like this. So I have used the more expanded format, so we are sighting up at our benchmark with an elevation of 246.75. We have a backside of 4.28 and an HI of 251.03. So I think you know how to do the math, but I just want to remind you. So we are set up here. See the first backside, 4.29. It's added to the 246.75 and so on. Now, SS-1, you should notice we have SS-2 and SS-3. They are for the southwest building corner, the southeast building corner, and the south rim of the manhole. So we have 3 intermediate foresights. So I'm going to, or side shots, and I'm going to label these or circle them, mark them off for you, because the difference here is that when you add and subtract your backsights and foresights, you are going to exclude them when you do your arithmetic check. The thing about a side shot and intermediate foresight is that there's no check possible. In fact, one of the best things, if I can go back to this previous slide, because there is no check, one of the things we often recommend is that if you possibly can, do this. When you set up at the second setup, also take a reading to the southwest corner of the building. When you're set up here, also take a reading to the southeast corner of the building. And when you're set up over here, that might be kind of hard, so it might be impossible, but see if you can figure out some way to take a second foresight reading. So these are like duplicate readings taken from a different setup to the same point, and you should get the same number, at least something extremely close to it. So you can do the same kind of thing as far as a math check is concerned. You can add the backsights up, you can add the foresights up and take the difference. So in this particular case, if I do that, we have 7 and 8 is 15 and 6 is 21. 4 and 7 is 11 and 2 is 13. 5 and 7 is 12, and 4 is 16. So 16.31 for the sum of the back sights. Now, when we add up the 4 sights, we don't include the ones that have been circled. Now, you can circle them if you want to, box them in or something like that, so that you know which ones you're supposed to add up. So we have 8, and 1 is 9, and 6 is 15. 5, and 1 is 6, and 6 is 12. 4, 8, 16. So we have 16.25 and 16.31. So if you subtract the 1625 from 1631, hopefully you can see that we get a plus 0.06. And now we look at our starting and our ending elevations, and yep, they miss by 600ths. So we have done our math check. We can't really check our intermediate 4 sights. Now, if we had done what I had suggested before, that from a separate setup we observe those side shots, then you could actually compare, because you would have a 249.04, and then from a different setup, maybe something exact like 249.04, maybe within 100th of a foot or something like that. And you can then decide you're going to average them or whatever it is to decide on what you're going to use. But doing the math check is essential, and do not assume that your field work is done until you have done that. As I said, you need to carry them as you go along, and you do not ever submit, whether it's a homework assignment or lab project, or actually when you go out in industry and start working, do not ever submit field notes without performing the math check. And so that concludes this particular discussion of the leveling process. Hopefully you will get used to this, because these are really some of the first few sets of surveying measurements that you're doing. And there are lots of things that I want to point out that can happen in the field that can cause problems. For example, one of the most common things is the rod being held vertically? Because if the rod is leaning back, or if the rod is leaning forward, and you have a horizontal line of sight, I think you can see that you might have different readings depending on how far from the vertical your rod is at the time. And one of the things I often suggest to people is stand behind the rod, don't hold the rod off to a side, always stand behind the rod, feet apart, keep your body straight, and you always put your hands on the side of the rod because you don't want to cover up the readings. You put your hands on the side of the rod, and one of the things that you will have read about is that you can do what's called wave the rod. Now when you wave the rod, you don't do it fast, you do it very slowly, and try to make sure that you're not going through an exaggerated arc. You only want to pass through the true vertical, so that the instrument person can observe what the lowest value on the rod is and use that number. So that's a very common thing that happens. You also need to learn how to read the level rod. So if we have graduations on the level rod, one of the things you need to get used to, and this, by the way, varies depending on whether you're using a metric rod or a rod graduated in feet, but get used to seeing numbers and graduations that look something like this. So you see the point here, and the point is on the upper half of the bar. So what this would mean is that we are at what I call a full foot, or a full tenth of a foot. And obviously a full foot would be a multiple of tenths of feet. So the bar has a point on the upper part. So if we work down, the bottom part of the bar is 9 hundredths or 100th below the full tenth. So the top of the next bar would be 8. The bottom of the next one would be 7. Then we would have a bar here that's a bit longer, but where the point, the sharp end, is at the bottom. And that's because we are now at a 0.05 foot interval. So again, starting at the top, 0.0, 0.09, 0.08, 0.07, 0.06, 0.05. And then we have a full bar, whoops. So that would be 4 and 3. And then we would have two and 1. And then we would have another long bar with the point on the top, the diagonal on the top, because we would be now a full 1/10 of a foot lower than the original long bar. So get used to using the long bars or the slightly less longer bar that have points on the top and the bottom to remind you whether you're sighting at a full 1/10 or a 1/2 or 0.05 value, and then count up and down. And it's a good idea to observe, take your eye away from the telescope, write it down or call it out, then look back in again and see if you get the same number. Especially when you're starting out, that's a very common mistake, to read the wrong number, which can lead to erroneous results. So always verify that. And the final thing is you have a circular bubble on your level. And basically the way the circular bubble works is that there's a mechanism inside the automatic level that always makes sure that your line of sight is horizontal as long as your circular bubble is centered. So before you start your observation, you always want to check that the circular bubble is centered, and after you finish your observation, just before you're ready to pick up the level, to move it up to another position, you want to check again that the circular bubble is centered, and if it isn't, then you repeat both your back sight and your foresight, because you don't know what happened in between, and you can't assume that your back sight was good and only your foresight was bad, for example. So just a few tips about things you can do in the field when you're actually surveying. And see you next lecture.